Hello. So we're starting our new video series on trigonometry, and this is the first one where we're going to be talking about basic terminology. We're starting with our first section, and the learning objectives for this section is to draw angles in standard position, convert between degrees and radians, also find coterminal angles, and find the length of circular arc. Use linear and angular speed to describe motion in a circular path. So by the end of this series of videos on this section, you should be able to do all of these things. Okay, so let's begin. So let's start with our basic definitions. And the first thing to note is that 2 points will define a line. There's only one line that can go through 2 specific points. And lines are usually denoted just by the name of 2 points that this line goes through. Okay, well, actually, it's not the most common way to denote a line. A lot of times we can just use a lowercase letters like L or M or K to basically name a line. All right, now another thing, if we only referring to a part of the line between 2 points, E and F, we're going to call this a line segment. And the way we denote it is EF with a bar above it. Now there is, or we could just state that it's a line segment instead, line segment EF, because also, honestly, this notation is also used for vectors. So this is not specific to line segment. Probably a preferred way just to state that this is a line segment EF. And when we say that, we're just referring to this interval between these 2 points. And another object, geometrical object, I should say, that we could specify using these 2 points is a ray. And a ray is a directed line segment. And it is, so we're also going to use our points EF, and above it, we're going to have this arrow saying that it's a ray. And what a ray is, it has a beginning point. Well, actually, it's called end point, but that's where it starts. So it does not continue in the other direction. This is the end of it, of the ray. And then it goes through point F and it continues on into that direction indefinitely. And that's a ray. Basically, you could think of it as of half half a line. So let's say we have this line here that's actually continuing indefinitely in both directions. If we put a point here, A, so this point divides the line into 2 half lines. Okay, so we can select another point here, B, and say we have one ray AB, and then if we put another point C here, and another half ray of AC, which makes this whole line. Okay, so a ray is a half line. It has an end point or starting point, and which basically this is a cutoff point, and then it continues indefinitely in that other direction. So that's ray. All right, so now let's talk about angles. Basically, an angle is the union of two rays having a common endpoint. This endpoint is called a vertex. So here in this example, we have two rays, EF and ED, coming from a single, having a single eight endpoints or coming out of a single point called vertex. Um, and we're going to say that these two rays, they are the sides of an angle. And so here, this angle, and we're going to denote it as angle DEF. Okay, so notice that first of all, we have this little symbol that denotes angle, and your endpoint of vertex is always in the middle of this angle, right? So we name it by the letters on the rays and the vertex is inside. So DEF, angle DEF. We could also name it, so this is a vertex in the middle. So we could also name it angle FED. That would be the same angle. And notice we could switch DEF, but E is always in the middle. Now, it is not always convenient to use three letters to identify an angle. Another common way to identify angles is to put a Greek letter inside that angle. Okay, so and in this case, the common Greek letters that are used, I'm gonna zoom in a little bit. All right. So that's letters theta. Those are all Greek letters. Theta, phi, which could be actually written in two different ways. Like I think this is cursive and this is printed. Also alpha, beta, and gamma. These are the most common letters used to identify angles, okay? I'm gonna write like them out in my handwriting so you could recognize them when I write them later. So this is theta, this is phi, or it could be this, alpha, beta, and gamma. So that's how I write them. So the next topic that I want to discuss is how the angles are actually formed. And so as we already talked about, we need two rays, right? And so first we start with two rays pointing in the same direction, and then one ray, while one ray stays in place, the other ray rotates. Okay, so basically it's a rotation motion that of the second ray that creates an angle. Okay, and this standard position of the ray is called initial side. Initial side. And so this direction from left to right in horizontally is actually called also a standard position. Standard position. So this one, the one that you're looking at, is in a standard position. Not all of the angles start out in the standard position, but if they do, so that's a standard position. Okay, and then, so then the second angle starts opening up, rotating, and finally it stops in this position. This is called a terminal side of the angle. Terminal side. Okay, and this rotation, which is measured in degrees or radians, but we're going to talk about radians a little later. So right now we're talking about degrees. This is the measure of the angle. Okay, measure of the angle. And sometimes in some books, the measure of the angle is denoted by this little symbol, like an angle, and with this little arc right here. So this is read measure of the angle. So it looks just like this. Okay, so and measure is in degrees. Um, so let's talk about degrees a little bit. So the you understand that when this ray starts to rotate, if it goes into counterclockwise direction, that's actually a positive rotation. And when it goes into clockwise direction, that's going to be a negative angle or negative rotation. Okay, so when the angle rotates all the way around a circle like this is a 360 degrees. So 360-degree rotation is a full circle. Okay, so but 1 degree, so this is a full circle. So 1 degree is actually, it's 1 out of 360 degrees. That's 1 degree rotation. Okay, so if you divide 360 by 2, that's going to be 180. So if you rotate only, if this second array rotates only half a circle, that's 180. But if it rotates a fourth, that's going to be a 90-degree angle. So from here, this is initial side, this is terminal side, that will be a 90-degree angle. Okay, now if we rotate in the opposite direction, that's going to be a negative angle. So if we start in this position and start rotating clockwise and stop here, that will be a negative 90-degree angle. Okay, now if we rotate, let's say, in a positive direction, and let's say that this angle, it stops like it's 90 degrees plus half of 90 degrees is 45. So that's, let's say that this is 120-degree rotation. And now our terminal side is right here. We could actually have the same position of the ray if we went in the opposite direction, okay, and also stopped in this position. So what would be, the question is, what would be this angle right here? Well, if the full circle is 360, so this would be 360, and we know that this portion is 120. So this portion is 360 minus 120. So that will give us 240. But it's going to be actually a negative 240. Okay, negative 240 because we're going in the negative direction, the negative rotation. So these, now what I want, the point that I'm making right now is that if you rotate this angle 120 degrees in the positive direction or 240 in the negative direction, then you end up in the same position of your terminal side. And these angles are called, they have a special name, they're co-terminal angles. They're co-terminal angles. So 120 degrees and negative 240 degrees are coterminal angles. Now, the thing about coterminal angles, in this case, like if you add the absolute values, they will add up to 360. But this is not always the case because what if, okay, you went 120 plus another 360, another full circle, you would still end up in the same position and your angles would be coterminal. So 120 plus 360, that gives you 480. So you could say that 120-degree angle and 480-degree angle are also coterminal angle, coterminal. Okay, because it will leave your terminal side in the same position. 120 and 480 will end up here in this position. So they are coterminal angle. And then of course you can go in the opposite direction as well. So minus 360, which will give you negative 240. Then you could subtract another 360 and get what? Negative 600. Yeah. Okay. So if you are asked to draw a 90-degree angle, well, how to do that? So for 90 degrees, we already know that you need to figure out which portion of 360 that's going to be. And we already know that if you simplify it, it's going to be 1/4. So 90 degrees is a 1/4 of the full circle. You're going to start with your initial position, your standard position. So that's in the opposite direction of the x-axis. And then you stop rotating in counterclockwise and you stop at the 1/4 of a circle. So that's going to be your terminal side right here. And this is going to be your 90-degree angle. And the 90-degree angle is usually noted by this square angle instead of drawing a rounded angle like here. For the 90-degree, we're going to denote it by this square thing. Whenever you see it, that means this angle is 90 degrees angle. Okay, so now how to draw a 360-degree angle? Well, you start with your initial side in a standard position, and then as we rotate, 360 is a full circle counterclockwise. So we're going the full circle. So this is your initial side, and then you come to your terminal side. They coincide. Terminal position or terminal side, they coincide for 360-degree angle. And since we define an angle in standard position by its terminal side, we have a special type of angle whose terminal side lies on the axis, and we call them quadrantial angles. So here they are, quadrantial angles. So those are the angles of 0, 90, 180, 270, and 360 degrees. So if the angle is 0 degrees, so its second ray does not move, so the terminal and initial side coincide, and this is the angle of 0 degrees. 90 is a quarter circle, so it points, the terminal side points up, just like here. And then we have 180. 180 is a half of a circle, so its terminal side points that way. And 270, it's actually 3/4 of a circle, so the terminal side will point down. Now, at this point, I would like to mention the quadrants. So that's where the word quadrantial comes from. So the two axes, one is x-axis, a horizontal one, and one is called the y-axis. That's the vertical one. Divides our plane into basically four equal parts, and those are called quadrants. Okay, and since our movement is usually counterclockwise, so the first quarter is called the first quadrant, the second quarter is second quadrant, the third quarter is the third quadrant, and the fourth quarter is the fourth quadrant. Okay, so this is we're going to be talking about quadrants a lot later, so please memorize these positions of the angle. So we're going to say that if the angle is ended up in this quarter of a coordinate plane, we're going to say the angle and is in second quadrant. Okay. So, and that would be between 90 and 180 degrees. Any angle between 90 and 180 will end up in the second quadrant. And that's going to be important. Here, I also wanted to mention or to remind you of some of the terminology that you probably learned earlier in your geometry class. But acute angle is an angle that's less than 90 degrees. Okay, so for the acute angle, its measure is going to be between 0 and 90. Now for the right angle, it's the angle that has the measure of exactly 90 degrees. Obtuse angle is the angle whose measure is greater than 90. So it's going to be between 90 and 180. That's an obtuse angle. And a straight angle is just, it's the angle that opens up at exactly 180 degrees. So we have names for these special angles. You know, the 90-degree angle is the right angle, 180-degree angles is a straight angle. Okay, and then the angle with a measure less than 90 is acute, and between 90 and 180 is obtuse. All right, so this is it for this video, and proceed to the next video. We're going to do some examples referring to these definitions that you learned right now.